Hello, students, and how are you today? I'm excited to be here. April is going fast past us. So today's the 21st, and our do now is really interesting. It's a prompt about appreciating the small wonders daily. Gosh, I need to do that more often. Just so nice to just let a little thing really bring you joy. So we'll talk about that. Our math objective is to continue with our one-step equations, and our essential question is how can I use those inverse operations to solve equations, okay? So our assignment today, we have do now, we have our work page, we have our exit ticket, which is a little something fun today. And remember, you've got to show me what you're doing because then I can see your hard work. So if you're a distance learner, make sure you either show it to me on camera or send me a photo to get credit. If you don't finish in class, you can finish for homework, but you still need to show me your work so I can be happy about how hard you're working. Remember, fourth quarter is well underway. Most important, are you showing your work to the teacher? We have a fun exit ticket. It's a gap fill puzzle, so we'll get to that at the end. But a lot to show you today. We have our do now. We also have, after our math lesson, I did give you, if you get done early, a little mindful arts activity. Today is Administrative Professionals Day. If you'd like to either make a digital or a physical card to give to our school secretaries, I'm sure they'd really appreciate it. So if you get a minute at some point today, and here's a website you can use that does really pretty digital cards, or you could just make something, ask your teacher for some paper. So let's be thoughtful of the school secretaries because they really make our school run. And then I do have a little game for you with all words that are kind of like synonyms for the word wonderful. So let's get to our do now and then we'll get to our lesson. So a lot going on today. We always have a fun packed Wednesday, right? So it's work from home Wednesday for you guys. We are in the classroom, the teachers, and I'm calling this Wonderful Wednesday because I want to think about bringing wonder into our lives with just small things. So I'll read. Small, simple events can bring us joy and a sense of wonder. However, recognizing small wonders might take some practice. How can we train ourselves to notice and appreciate small wonders daily? That's something you have to consciously think about doing. You can get so busy going from class to class and assignment to assignment, and then chores at home and things people you want you to do for them, and friends that want you to hang out with them. You don't get a minute to just say, wow, the weather's really beautiful. The sun is nice. Look at the pretty forsythia bushes right now. It's so pretty outside. Or, oh my gosh, my friend just gave me a pretty card just to say hello. What a great thing. Pick something small and let it bring you wonder. So, and if you think of something like that, how can you train yourself? Could you say, I'm going to wake up and I'm going to look for something wonderful today? I'm going to tell myself that. So, if you have something wonderful to share or a thought about finding wonder, why don't you write it right there? So let's get into our lesson. Okay, so we're really working on those one-step equations and we're focused on using those inverse operations so that we can solve those equations. Sorry about my phone, I apologize. I'm at home right now doing this. So hello from my house. So remember, first we ask what is happening to x or y or z or n or a or whatever the variable is. And then we're going to use those inverse operations to untie x, untangle it from the equation so that it's isolated, which means by itself, and we'll know what it is worth, what its value is. So, and remember, we finish every one of these with x or whatever variable equals a number. So let's get started here. Okay, we have x. What is happening to x? It's being divided by 7. Fraction is division. So what's the opposite of division? It's multiplication. I'm going to rewrite this so that you can see the steps I use to solve it. So x is being divided by 7, so the inverse would be to multiply by 7. Whatever I do to one side, I do to the other. And so then our 7 over 7 cancel because they become 1, and we have x isolated, and x equals 4 times 7, 28, and that's a final answer. If you substitute 28 divided by 7, you will get 4, and our answer will check. Number 2, what is happening to n? N is being 19 is being added to n. So the inverse of adding 19 is to subtract 19, and we know that whatever we do to one side of the equation, we do to the other. So 19 minus 19 is 0. So on the right side of the equation, we have our n isolated, and 10 minus 9 is negative 9. And I like to write it with the variable on the left, n equals negative 9, although the other way is correct as well. If I substitute negative 9 for n, 10 equals negative 9 plus 19, negative 9 plus 19 equal 10, my answer will check. So number 3, what is happening to m? Well, 7 is being subtracted. So the inverse of subtracting 7 is to add 7. So on the right side, we have 7 minus 7 would be 0. So we'll have m isolated on the right side. And on the left side, negative 13 plus 7 is negative 6. So m equals negative 6. And if we were to substitute negative 6 for m, negative 6 minus 7 would equal negative 13, and our answer would check. Now, number 4 is a multiplication problem. What is happening to k? K is being multiplied by 4. So we have 4k equals 54. So if something is multiplied, the inverse would be to divide. So let's divide out the 4. Okay, and so 4 over 4 equal 1, so that gives us 1k, and 54 divided by, I'm sorry, that's 52. Yeah, it makes more sense to me, 52. 52 divided by 4 is 13. And if we were to substitute 4 times 13, we would get 52, and our answer would check. So number 5, what is happening to k? Well, negative 16 is being added to k. The opposite of adding a negative number is adding a positive number, in this case 16, but we need to do that to both sides of the equation. So that would give us k equals negative 11 plus 16 equals 5. Now in number 6, we ask what is happening to w. W is being multiplied by negative 8. Please remember to include that negative sign. So instead of multiplying by negative 8, we will divide by negative 8, which we must do to both sides. So the negative 8 over negative 8 equal 1. So that isolates our w, and 72 divided by 8 is negative 9. 72, a positive, divided by negative 8 is negative 9. And if we substitute negative 9 for w, negative 8 times negative 9 will give us positive 72. So that answer checks as well. Now in number 7, I'm going to rewrite this one. 3 equals v over negative 6. So what's happening to v? V is being divided by negative 6. So the inverse operation is to multiply by negative 6, which we will do to both sides of this equation. That isolates our v on the right, and on the left we say negative 6 times 3 is negative 18. So v equals negative 18. Now, number 8, we have 24 equals c minus 17. So what is happening to c? 17 is being subtracted from c. The inverse of subtracting 17 would be to add 17. And why do we do that? So we can isolate C, and we must do that to both sides of the equation. So now negative 17 plus 17 equals 0. And 24 plus 17, well, 7, 4, and 4 make 11. 2, 3, 4, so C equals 41. And if we were to substitute, 24 equals 41 minus 17, our answer would check because 41 minus 17 is 24. So this is a correct answer. Now I'm going to rewrite number 9, so I have a little room to show you what to do. So it's number 9 says r divided by negative 4 equals negative 15. So we ask what is happening to r. It's being divided by negative 4, and the inverse of division is multiplication. So we will multiply by negative 4, knowing that whatever we do on one side of the equation, we do to the other. So negative 4 divided by negative 4 equals 1r, which means our r is isolated. So that's the left side of the equation. On the right side of the equation, we have negative 15 times negative 4, and negative times a negative is a positive. 15 times 4 is 60. And that is our final answer. Number 10, we ask what is happening to k. 37 is being added to k, and that equals 54. So instead of adding 37, we will subtract 37 from both sides. And 37 minus 37 equals 0. So on the left side of the equation, we have k. On the right side of the equation, we have to subtract 7 from 14 is 7, 3 from 4 is 1, so k equals 17. If we were to substitute 17 for k, 17 plus 37 equals 54, and our answer checks. Now be careful when you get problems that look like number 11. We have an invisible 1. We can think of this as an invisible negative 1 times w equals 16. Okay, so we have an invisible negative 1 there. So what we need to do in this case is we need to divide. We can think of this as multiplying by negative 1, so we have to divide by negative 1. And whatever we do to one side of the equation, we do to the other. So negative 1 over negative 1 equal 1, which gives us 1w, that's another invisible 1, equals 16 divided by negative 1 is negative 16. And that is our correct answer. So for number 12, negative 27 equals 9h. So we ask what is happening to h. When you have a letter and a number next to each other, they are being multiplied. So h is being multiplied by 9, and the inverse operation would be to divide by 9. So we're going to do that to both sides of the equation. On the right side, we have isolated x, which was our goal. On the left side, we have negative 27 divided by positive 9, which is a negative 3, and that is our final answer. Number 13, this one's a little bit tricky because we have 4 equals negative 4 plus a. When we say, what is happening to a? Negative 4 is being added. So we're going to add not negative 4, but let's just add positive 4. But whatever we do to one side of the equation, we must do to the other. So now we have negative 4 plus 4 is 0. So we've isolated a on the right side. And on the left side, 4 plus 4 equals 8. So a equals 8. And I usually, like I said, like to write it with the variable on the left side. So I would write a equals 8. I put a plus sign. I meant to put an equal sign there. So in number 14, we have s divided by 8 equals negative 5. So what's happening to s is that it is being divided by 8. So we're going to multiply by 8, and we're going to do that on both sides of the equation. So the 8 over 8 will cancel out because they equal 1. Anything over itself is 1, but we have isolated s, and s equals negative 5 times 8, which is negative 40. So number 15, we have 27 plus p equals 11. With this problem, it's important to note that that 27 is positive. Okay, so we're adding a positive 27. So what we want to do is add a negative 27. That would be our inverse. And whatever we do to one side of the equation, we'll do to the other. So 27 minus 27 equals 0. That leaves us with p equals 11 minus 27, which would be positive 16. Remember, we subtract and keep the sign of the larger absolute value. So p equals 16. Then number 16, we have 0 equals negative 7k. So k is being multiplied by negative 7, which means we're going to divide by negative 7, and whatever we do to one side of the equation or inequality, we're going to do to the other side. So negative 7 over negative 7 equal 1, which means k has been isolated. And then we have 0 over negative 7. Anything with a 0 in a numerator equals 0. Looks like it's okay, but we could also write it k equals 0, KO. All right, number 17, c minus 4 equals negative 23. And we're going to ask what is happening to c, and we see that 4 is being subtracted from c. So that means we add 4, and whatever we do to one side of the equation, we do to the other. So 4 minus 4 is going to be 0. We are going to bring down the c and the equal sign, and negative 23 plus 4 is negative 19. And then moving on to number 18, I'm going to rewrite this. Negative 16 equals r over negative 2. So what's happening to r is being divided by negative 2. So the inverse operation would be to multiply by negative 2. Remember to include your negative sign. And we have to do that to each side of the equation. So negative 2 divided by negative 2 equals 1. So that gives us 1r. We've got an invisible 1 there on the right side of the equation. And negative 2 times negative 16 is a positive 32. And that's our final answer. And you can check all of those by substituting your answer for the variable. Now, number 19, we have a word problem. Well, it looks like Amanda has done some work. Amanda's work, and it's my favorite. I love error analysis. That's what this is. So Amanda's work and solution to the equation negative 4k equals 20 is shown below. Is she correct? If not, correct her work. So let's see what she did. Negative 4k equals 20, and she added 4 to both sides. Well, that's a problem because she thinks that 4 is being subtracted from k. That is not the case. Negative 4 is being multiplied by k, so she needed to divide by k. So let's redo her work. So negative 4k equals 20. So let's divide by negative 4, include the negative sign, and what we do to one side, we'll do to the other. And then we have on the right side, k equals positive 20 divided by negative 4 is negative 5. And then our last problem of the day, Ryan's work and solution to the equation negative 16 equals negative 1 plus m is shown below. Is he correct? If not, correct his work. So I see negative 16 equals negative 1 plus m. So we've got what's happening to m. Negative 1 is being added. But look what he did. Instead of using the inverse operation of adding a positive 1, Ryan added or subtracted a 1, so that part is incorrect. I'm going to write no. So let's redo Ryan's problem. Negative 16 equals negative 1 plus m. So we need to add 1 to both sides. And I'm going to change my color. This will cancel. On the right side, we have m. On the left side, negative 16 plus 1 is negative 15. And we can check that if we have negative 16 equals negative 1 plus a negative 15, negative 15 and negative 1 are negative 16, and our answer checks. So let's go back to the exit ticket. I told you I had something a little interesting, different for you today. So we are going to do this gap fill puzzle. So we have 1, 2, 3, 4, 5, 6, 7 words. And we have 7 blank spaces. So let's see. To blank an equation, you must solve for the blank. You must identify what blank is happening to the blank, and then use blank operations to undo the operation. When the variable is blank, your equation is blank. Okay, let's see. To solve an equation, so we did that, you must solve for the variable. So we'll use one of the variables. Okay, you must identify what blank is happening to the blank. You must identify what operation is happening to the variable. That's X or Y or A or B. And then use blank operations. We're going to use inverse operations to undo the operation that's happening to the variable. When the variable is isolated, right, all alone, your equation is solved. Okay, good job today. You guys are really catching on. I know this is still a lot of new stuff we're doing, but I can tell you're practicing and you know how it works. It's not about being a genius. It's about practice. And with practice, you'll be great.